Hey, Probstats kids, this is Dr. Callahan with week 15 Thursday. How are you guys doing? Here are the following 3 questions for your warm-up log for week 15 Wednesday. So make sure you guys pause the video and answer them. All right, so let's go ahead and get started with today's stuff. So this is the worksheet that you're going to need in class. And we're going to start from the very beginning. So the traveling salesman's problem involves the Hamilton path and circuits. And basically, it's just a traveling salesman, has clients in 5 different cities. He's known the cost of travel between each of the pair of cities, and he would like to start at his hometown, travel to each of the 5 cities, and then eventually return back home, of course. So what is the cheapest way to make this happen? Keep in mind that when we talk about the Euler circuit, it covers the edges of the graph exactly once, and the Euler's path covers the edges of the graph exactly once, but it starts and ends at the same point. On the other side, a Hamilton's path is a graph that includes the vertex of the graph once and only once. So you're just meeting the point once and only once. And the circuit is that it is a Hamilton's path, but it also starts and ends at the same point. So for example, if I take a look at this diagram right here, start at A, F, B, E, D. So I'm touching all the points, okay, G, and then C. So that is a Hamilton's path. Now for the circuit, or for the Eulers, you want to touch each of the edges. So A, F, B, A, D, C, B, E, G, C. So notice a difference in the path between the green highlight and the red dots. All right, so let's go on to the next one. Find the Hamilton's path that starts at G and ends at E. So go ahead and pause the video. One possibility is this one, where if you go ahead and start at G, and this is a path, so you're dealing with a vertex, go from G to D, D to A, and we're touching all the dots, A to F, F to B, B to C, C to E. To find a Hamilton circuit for the graph that ends at A. One possibility is you start at A, you go to D, G, C, E, B, F, and then you're going back to A. Is there another way to write the same set of edges using the same starting vertex? Yes, it is very possible. So if you go from A to all the way to F, and then from F to B, B to E, E to C, C to G, G to D, and then back to A. So this right here is a Euler's circuit. This one here is a Hamilton's circuit. And the first one is a Hamilton's path, because you did not end with the same point that you started off with. It is very possible for you to write the circuit backward. It's called a mirror image. So here are another way to write the same set of edges, but you just simply start with a different vertex. So with this situation, what you're looking at is C to E to B to F to A to D, and then to G. So really what this is a mirror image of this one to this one right here. You're just simply going backwards. The vertex you start is always called the reference point. All right, next part, let's take a look. I want you guys to trace a Hamilton circuit on the graph right here. The way you'll do that is start from A, and from A, you will go to B, D, C, E, F, G, and then A. So you're touching all the points. Now let's label the mirror. Your mirror consists of the inside here reversing, but the beginning, start, and end one are exactly the same. So these are the same. but the inside are reversed. So if I were to go by that path, I will start at A, G, F, E, C, D, B, and then back to A. All right, name it from two different reference points, which is the starting point. So I can go ahead and start off at a different point as well. Let's say we start at C. So from C, I go to E, and then from E, F, G, A, B, D, C. And another way that you can do this is from G, and then go to A, B, D, C, E, F, G. So again, different starting and end points. All right, to complete a graph, it's where each of the vertex is adjacent to every other vertex in the graph. We use that to represent as K sub n, where n is a number of vertex. So I would like you guys to go ahead and draw a diagram that has 3 vertex. So for example, here's 1, 2, and 3. 3 different points. 1, 2, 3. And you just simply connect it. Now I want you to draw a diagram that has 4 vertex, 5 vertex, and 6 vertex. So pause the video and do that. This is my 4 vertex, 5 vertex, and then 6 vertex. Okay, now turn over to the back of your papers. So with this, I'm going to talk about formulas. Okay, so first things first, find the number of vertex. It is just n minus 1. The number of total edges is n times n minus 1 divided by 2. And then the total number of Hamilton circuit is n minus 1 factorial. Okay, so at this point, take a look at the answers. I want you guys to find the Hamilton circuit. That's all I need to know. Will do. And take a look at the answers here. You're just simply using the formula n minus 1 times the factorial. All right, so then with that said, how many edges are there? If you're looking for the edges, this is the formula you're going to be using. Plug that into these formulas here. 171 edges, and then 11,175 edges. Let's do the same for 3, 4, 5, and 6. And go ahead and fill in the rest. All right, you guys, at this point, we are pretty much done. Make sure you guys go ahead and do this on a separate piece of paper. I want you to create a diagram that meets all the requirements for a Hamilton circuit and Euler circuit. Create one diagram that meets both conditions and it's 5 or more vertex. Have a wonderful day. Take care.